All right, welcome back, everybody. We're going to do another stream about Quilibrium, and we're going to be talking about some news that's happened, as we've been doing a lot lately because there's been a lot of impacts from that. Talk about an update around Q1, and then we will get around to a dev talk. And we've got 3 different topics that we're going to be tackling for that. As always, a disclaimer, the discussion today is not a solicitation for investment and is not financial advice. The Quill and corresponding wrapped Quill tokens discussed on this broadcast are utility tokens, and Quilibrium Inc. does not endorse or encourage engaging in speculation on the utility token of the network. Also, as always, we talk about the mission of Quilibrium. Our mission is to secure every bit of traffic on the internet, whether it is on Quilibrium itself, in service of other crypto protocols, or the broader web. Now, today, our agenda is going to be a few news items, some relevant to the world at large, some relevant to Q itself. Then we're going to dive into a 2.1 status report and some recent updates, including some stuff that transpired over last night, which is super exciting. And then finally, we will get into the 3 dev talks. One of them is a little bit more general purpose, so we're going to do that one first, and then we'll dive into the deeper details later for folks that want to stick around for that. We know that that tends to get a little bit less active at the end. So let's go ahead and start things off with our news. So quick updates. One of the things we've been talking about a lot is Apple, specifically that Apple has been caught in the crossfires of the UK's rules regarding, basically it's the Investigatory Powers Act. It's kind of like the UK's more extreme version of the Patriot Act in the United States. And one of the things that the Investigatory Powers Act does is it can mandate that companies basically are forced to decrypt content on behalf of the requests of their secret courts. And Apple has apparently received one of these requests, and it is forcing them to essentially strip the advanced data protection from their devices in the UK. It is a complicated situation. They obviously did switch out to the non-encrypted version. They removed ADP. But are you lagging or stream? I'm not sure what you're talking about. I do have kind of like weak connectivity today, so bear with me. I will also re-upload this recording afterwards so that it's... Okay, cool. All right, so anyway, yeah, so Apple was basically forced into this awful position. And we've seen some back and forth between the US government and the UK government, and it appears that now Apple is at the point where they are actually suing the British government, and they're pursuing this case through these secret courts to push back on this. This is good news, but nevertheless, we are continuing to monitor this case because it actually affects a lot more than just Apple. It affects all the companies that do business in the UK. Right now, we do not do business in the UK. We, in fact, refuse on these specific grounds because it's just too dangerous of a situation for us this early to get involved with. But as time goes on, there's going to, of course, be an international presence that Quilibrium Inc. will have, and so we're going to have to always take the proactive stance of ensuring that we do not get caught in the crossfire of a situation like this. Of course, the protocol is built such that it doesn't matter if we receive such an order. The protocol will continue to function without the ability for such a backdoor to be instilled. However, it is the nature of the beast that these types of pressures will come eventually, and it's something that is part of our expected fight that we will also have to fight. This is why we are a member of the Global Encryption Coalition. Next up, speaking of Apple, Apple developer status. We're at the home stretch with them. They've had a few back and forth items I've had to resolve with them. We're going to be making an update to our website to incorporate some details that they need. In particular, they want like a terms of service, and then they want a privacy policy, which these are reasonable expectations to make out of tech companies in general for your products. In our case, since we're an open source project and we're also a privacy preserving project, the privacy policy is we don't record data on you. So our terms of service is going to be relatively like standard boilerplate. Just, what will make Apple happy. Our privacy policy is going to be a lot less standard than your typical privacy policy, where, they talk about the litany of data we collect on you, and in our case, it's going to be nothing. We collect nothing on you, and so that's going to be an interesting thing, and it may be some fun marketing that we can do along with the event. But the net result of getting this Apple developer account is that we're going to be able to begin rolling out our Quorum Mobile beta for iPhones and Android. Now, last thing of note regarding news, We now have a marketer on the team. I think I believe you've seen some of their handiwork in recent posts that the Quilibrium Inc. account has been making. They're getting a lot more engaged on Twitter, and I think that it's going to be interesting to see how that develops over time. Very excited to have them on board. They're very good at what they do, and I think that they're already starting to make a pretty good impact. So that brings us to the last item, which is the 2.1 status report. So if you're in the testnet chats, you've probably already seen all of this information. But we are at the point now where Hypersync, which has been this long story that we've been trying to get through to get to the final 2 tests of the Milestone 5 part of testnet's 2.1 release. We finally gotten to the point where 3 nodes have fully reached 100% of the total data synchronized across peers and built up in the local hypergraphs. What's very interesting now is that when we run rebuilds, those rebuilds run very quickly. I've actually tested this locally, and it's processed now. The speed of the hypergraph has gotten to the point where it's about, if I was to try to reason about this in terms of single event writes per second on a very overloaded hypergraph, that is approximately 725,000 events per second, which is just staggering. But we've needed this because we need to be able to relay all of the data replay all of the data that has happened on mainnet and ensure that it safely encodes, is interoperable with the updates that are coming as part of the rest of 2.1. So it's been a real pain. I know that it's been really frustrating to, if you haven't been part of the testnet, to just see that this has taken so long. But the net benefit has been, significant improvements in performance, reliability, and also the fact that this is going to have dividends in additional applications for people trying to build things where you need large amounts of data synchronized between multiple peers for the sake of your application. This will obviously be used for Quorum. Our current sync algorithm's not very great on that, and so we'll be adopting Hypersync proper into Quorum in order to speed that up as well. And that's where we're at. So we'll have, once this has been verified that the actual finalized state is where it's supposed to be, we'll be moving on to the QCL testing and then removing the testnet beacon from the network. And if those 2 things are wrapped up, then 2.1 will be ready for mainnet. All right. So there's a few different topics that I wanted to tackle tonight. One is sort of dev-oriented, and so I'm going to put this one first. The first thing is going to be talking about a little bit of a history lesson. I know a lot of people have seen some interesting events over the past few weeks, and more events happening today that have been pretty hard to stomach, especially if this is your first season in crypto. And I think it's important to understand, I've said this many times, and you'll hear this from pretty much every single person who has ever been an employee at a Y Combinator style company, or Coinbase specifically, because Brian loves to talk about this a lot. But it's a really true phrase, which is it's never as good as it seems, but it's also never as bad as it seems. Even when things seem really rough and everybody is saying this is the end, it's so over, the reality is that there's always going to be extreme emotions tied into speculative bubbles. And that is what we are in. We are in a speculative bubble, and we've been in one for quite some time. And so one thing I want to level set with people is to have their expectations in line when they think about this industry in a broader narrative. And more specifically, what we're thinking about and how we think about the nature of what Quilibrium Inc. is going to be playing in the part of writing the stories of that future. And so I want to just draw a couple of parallels real quick. First thing I'm going to do is I'm going to switch this over and hope to God it works. Of course it didn't. Okay, so yeah, I've been having some troubles with Streamlabs. Let me get that sorted out. Hey, there we go. Okay, so anyway, I've got Excalidraw open because we're going to have a couple of items that I'm going to draw out as I paint the picture of 3 different stories from history that inspire me a lot and make me think a lot about what the future of crypto is going to look like. So to start things off, we'll wind the clock back to 1970s. In the 1970s, there was this idea of the homebrew computer. People were first starting to learn about computers in like a more personalized context, because before, you had like the ENIAC and these big vacuum tube filled machines, and then the advent of the transistor started to shrink technology down, so these computers were not actually taking up the full size of a room, and eventually like things were getting down to the mini computer. And around the 1970s, technology had gotten to the point where people were actually starting to experiment personally. Like they were starting to build out their own home computers. And there were lots of schematics that were passed around through these homebrew clubs. And there were also starting to be some consumer-oriented hobbyist computer devices. But at the end of the day, these were all like very nerdy devices. Like you had to have like a breadboard that you hand wrapped and wired yourself, and you had these like very huge books that were like guides on how to actually set this all up, and people just didn't actually really care. Like if you were a normal person that was not a nerd, that you could see these things and you could be like, that's really neat, but that's never going to sit on my desk. Like people are saying this is the future, but I just don't see it. But one thing you have to think about is what came out of that. So during the 1970s, there was one particular homebrew club, the Homebrew Computer Club, very aptly named, and there was a trio of individuals there that ultimately became the founders of Apple Inc. And they introduced a personal computer at the Homebrew Computer Club called the Apple I, and it was pretty janky. I've talked about this in previous streams and actual talks that I've done at like FarCon and a talk I gave at Coinbase. And this device was a very clunky wooden thing, and that was the prototype. But nevertheless, it like changed the narrative a bit, because instead of people having to, manually build these things themselves, it was something instead that people could buy. Like it was a consumer-oriented device, and it was something that really started to challenge the narrative of what a personal computer was and what that actually meant. And so you started to see this change in the industry that companies were slowly working towards and building, where you had what was the previous, industry niche of the mini computer, and IBM being very slow to pick up on that. And then you had the advent of the personal computer, and again, IBM was very slow to pick up on that. But by around the 1980s, the personal computer had started to take off, and people were actually using it for things that was more than just like geeking out. Like people are starting to actually use these for financialized applications. And so as these offshoots started to spring up, you started to see competition occur within these industries, because there was suddenly an influx of money that was accumulating from all the different entrants. And one of the things that was really important to notice is that a lot of engineering went into this, because these people were obviously talented hardware engineers, and they may have worked in other industries that were adjacent to this, but trying to like compress everything down into the most cost economic way for a business to produce it, but still functional means for a consumer to do powerful things that they couldn't do before. Like back in the day, you were doing spreadsheets by hand, and now you can do spreadsheets on a computer that can sit on your desk and you can print that out, and that was very novel. But ultimately, like things started to move beyond just basic finance. But there were some companies that couldn't get past that. That was their bread and butter. They sold to accountants. They sold to business leaders, and that was it. Like that, they thought that that was the depth of computing. And so you didn't really have a whole lot of people who were like teachers or creative artists or anything like that had quite gotten into the realm of using a personal computer. And through the conversations that Steve Jobs and others at Apple had with individuals who are working in those industries, he realized that the personal computer was not personal enough, that there were things that needed to be done that moved beyond finance. And at the time, that was basically received by the industry as a joke. People did not think that that was necessary, that there wouldn't be money in it, that people wouldn't have a computer on every single desk in their home, like that this wasn't going to be something meaningful, but he thought differently. And by consequence, Apple quickly seized the entire market for education, seized the entire market for creative types, and ultimately blossomed into the Apple ecosystem that we know and love today. And I think about this lesson a lot, because it's one of those moments in history where people are looking back at things like the early days of crypto, where we are just beginning to eke out this idea of decentralized finance, that we're, challenging the notion of fiat rails, that we're challenging the notion of just the sheer concept of interchange of value. And ultimately, things continue to develop and created new ecosystems. You have these new chains that emerge that start to expand the capabilities and start to create these new ideas and more complexity. And ultimately, what I'm seeing is that exact same pattern play out again. We are seeing the world of crypto focusing just on finance. When you start to see things like people focusing on creators, like they'll talk about the creator economy, what you'll notice when you listen to what they're saying is that when they talk, they are talking about putting creators into a financialized topic, like putting art on chain, putting music on chain, and selling these things as NFTs. They are strictly focused on the financial. They're not focused on the things that artists personally care about. Because yes, to an artist, there is a business side to them, but they are not strictly in the business of art. They are in the passion of art. And it's these types of things that I feel like our industry is just completely glossing over. And it's something that's going to blindside them when there is actually something much more capable and much more adept at handling what it is that these individuals actually want to do to pursue their passions vigorously. And so this is just one of the three aspects of history that I think is playing out in a little bit of repeating. So the way that I think about this is talking about the axis of what you can do and what happens when the world starts to change that idea. The second thing I want to talk about is something that will feel very, unfortunately, at home right now. The video game crash of 1983. So in the 1980s, the video game industry was largely dominated by Atari, Magnavox, and a few others, and what essentially was this idea of like home video game systems that you'd release a new one every couple years. You'd be like pushing out a bunch of video games that were like usually brand deals. Like, there was the most infamous one, of course, was the E.T. video game that was released during the E.T. movie. And that was, those types of games that were coming out were like mass produced, very quickly built, not very great. And by consequence, over time, there was this cycle of people pushing out new consoles, pushing out a bunch of rehashes of the same games with the same rules, with the same ideas. And after a certain point, it was reaching this market saturation level where people did not actually want to buy a new console. They didn't want to buy these games because these games sucked. And by about 1983, which was roughly the peak of the video game industry, they were sitting at about 3.2 billion in total revenue that year for the video game industry, which is quite a bit. That's about $10.2 billion in current dollars. But in roughly 2 years, they completely cratered down to an annual revenue of about 100 million. Why is that? And ultimately what it comes down to is people were being flooded with a bunch of shit that they didn't want. And it's that simple. And so you can, again, there's this parallel that you can start to see where, like right now with the various hype waves that have happened in crypto, you have like the original like ICO hype, the NFT hype, even DeFi Summer had its own unique hype because it certainly propped up a bunch of algo stables that ended up being pieces of shit that wrecked people's lives. And then you have, of course, the current meta of the meme coins, which is starting to, again, reach that market saturation where people are realizing, this is shit. I am just gambling. Why am I doing this? And so we're starting to see like this, financial rejection in play. Obviously, there are broader market consequences that are happening right now, and people will have all sorts of theories about, how it's the tariffs that are doing this, or it's some other like longer economic story like a recession that's been impending for a while that's playing out. But in reality, we are actually seeing that same kind of crash, that same video game crash that happened in the 1980s. And so what I want to talk about with that story is what went wrong and what got fixed. What led to the video game era that we know as today, because like most people, we've played video games and we don't really think about the infamous Atari landfill because that's such a transient moment of history. Like it's not something that, was the cornerstone, that was the end. Like we just remember the Atari landfill and gaming was gone. Of course gaming's not gone. And so what happened? Essentially, these analysts were basically, they were dooming Atari, they were dooming Magnavox because obviously they were in, bad financial state. And they were saying that this is the end of home gaming industry because in the 1980s as well, home computers were starting to rise. And so they were blaming home computers and the poor quality of games, of course, as the reason why the game industry was over. And what's interesting about that is that by 1985, there was this small, well, I wouldn't say small, but there was this relatively unknown game company, unless you were like frequenting the arcades, that made mostly playing cards in these arcade games, and that was their entire business. And they were based out of Japan, and they re-envisioned how to approach the gaming industry. And what they thought was, we need to think about how American consumers currently see this industry. And they see it basically as them getting screwed, like they're getting ripped off, like they're not getting a good entertainment experience. And so what they did is they set up a quality bar where you had to, as a game publisher, you had to meet this quality bar before they would license your game to run on their console. Because what was happening with Atari is anybody was just hucking games and there was no quality bar at all. And so ultimately, Nintendo released the what was the Famicom in Japan as the Nintendo Entertainment System in the US. And they stylized it like a VCR so that people would more associate the common elements of home entertainment systems for like watching movies and things that they already had like strong quality experiences wrapped around. But instead with video games. And so they had the Nintendo Seal of Quality, which was their quality check and gate that prevented crappy games from ending up, being distributed and destroying the industry. And of course, history was made with that. The NES is a cornerstone of video game history. Nobody has like seriously bad things to say about that moment in time, except maybe having to blow into the cart too many times because the game didn't want to start. But outside of that, like it was a watershed moment for the industry. It changed how things were done. And so I want to talk about this in the lens of what's happening in crypto in the sense that we are seeing that same failure. We're seeing the quality failure of both things like the memes, like not just meme coins, but like the mimetic tendency for people to jump on hype trains of like completely unchecked assumptions or completely lack thereof of assumptions, like this financial degeneracy. There's just no quality gate on these things that's resulting in people making very poor financial decisions. And ultimately, like it's burning people and it's making people feel like crypto is a scam and that there's nothing good in it. And that comes entirely from the fact that we have a lack of quality enforcement. So I wanted to talk about that because this was the problem that Nintendo solved that was unique and what positioned them to be so different. The final thing that I want to talk about as a story of history repeating was the dot-com bubble. So in the 1990s, there was a cadre of early internet companies. A lot of people saw the early days of the internet as this unique idea that let people exchange information in ways that were much more personal than, having to call somebody and that's all you get. Maybe a group phone call, but that's expensive. And so like it was connecting people in unique and interesting ways. And it was also introducing multimedia to people in ways that previously it was very much a non-interactive model. You would watch TV and there would be big producers of television programs. But instead, this became something that was more interactive. And so there were early companies that were starting to jump on top of this. Now, of course, at the time, we didn't have significant bandwidth, so there wasn't, you couldn't do live chats over video. You couldn't have streams like Twitch. Like, these things were not yet viable because the technology was lacking at the time. But nevertheless, the dreamers and the idealists of this created these very large companies. You'd find them in the field of search engines like Google kicking things off, Alta Vista, Yahoo, of course. You had these e-commerce companies that started to differentiate into small silos like Pets.com, very, very infamously. And then you had even online delivery services. The very first case of online delivery, if you want to call it that, was actually like Pizza Hut had opened up a online portal where one specific Pizza Hut was running a server that would take these requests in, and then they would just basically send it out to all of the different Pizza Hut branches across the country. And that was how they kind of like kick-started the whole idea of online delivery of food. And then there was also actual online delivery of restaurants that was attempted in the late 1990s. Very few people remember it because it wasn't successful. And then there was also, of course, the internet service providers. Like you had your CompuServe, you had Prodigy, you had America Online or AOL, and then you started to see this shift. Early 2000, around March or so. There were so many of these companies that had propped up these IPOs, and they were, after it all. They were trying to dominate the market under whatever it was that they were trying to do. And realistically, they didn't have business plans that panned out under the current state of the technology that existed at the time, the progress and trajectory that technology was able to make during that time, and of course, you had a broader economic conditions that were starting to push down on things. And so by consequence, you had what was the dot-com bubble bursting. And there were a few companies that had just started shortly before then. And oftentimes they were in some of those domains that were ending up largely producing a bunch of failures of companies. So you had Yahoo and Google, you had Amazon and eBay. And besides AOL, you had like this cadre of small internet companies that were starting to get into more niche services like high-speed broadband, because at the time that wasn't niche, it was expensive. And they were laying down the groundwork of things that they knew were going to take a long time to achieve. And the market, of course, punished them significantly, but they made the right decisions to ensure that they were in it for the long haul, that they were making generational decisions that they'd be able to capture or capitalize on in the years to come when everybody else was making these short-term decisions that were just not feasible for a business. And so, as a consequence, after the dot-com bubble bursted and all of these other companies had died out, you then had basically Amazon, eBay, PayPal, of course, from the eBay generation. You had a few different ISPs, and you had, of course, Google and Yahoo that were basically dominating the industry and becoming titans. And so this is what I'm basically seeing, again, to draw a parallel in crypto today. Unlike the other two categories where it's the difference of what you can do or a quality enforcement bar, in this case, it's a planning for long term, like planning for the long-term generations of what technology is going to be able to enable. And so these are the three pillars that I think of historically as playing out in crypto all at the same time. And there's a lot of overlap, of course, in how these stories played out and the ideas that formed around them. But I think it's important to think about these because these parallels are how we are defining what we're doing as a company and what we're doing for the protocol in order to ensure its long-term success. And so what I think about in terms of like what you can do in the context of what can we enable, we think less about finance. Finance is a part of it. But finance is just an application, more about what other people need, what other industries need. And we think about, I don't know why it's auto-completing there, that's super annoying. We think about what type of creative works can be enabled. Because when you talk about the problems that technology solves, when you're trying to design something, if you're designing something just simply for the sake of trying to basically create a solution in search of a problem, which is something that typically gets flung at the crypto crowd. And it's because what people are solving is something that is novel. Like, it needs to be something novel or else nobody's going to use it. And so what crypto actually uniquely solves in applying those properties of what crypto uniquely solves is something very valuable. So what I said with the creatives, for example, like in the industry that Apple tackled with education and creators, what was missing was the tools they needed in order to acclimate to the digital world. So they didn't have quite the easy tools to develop digital art. And so Apple was pushing into that audience, getting more tools built in that ecosystem to support those artists to do those things. And so from our standpoint and what we think about what creators are having problems with today, this is where we get into some topics that are pretty contentious. But the topic of the way that AI art has damaged artists in the sense that these models are basically being trained on artists' content that's been posted in like public websites and stuff. And these artists aren't being compensated for this training data. And then the art that gets produced by these machine learning models is something that is so derivative, but like so derivative of such a mass of different things that you can't uniquely link it to the original creators of those art pieces. And so by consequence, they also get no attribution. They get no reward, they get no attribution, and they didn't get to actually have any say in whether that data is being used to train. And so this is something that I focus on in the way that we're trying to promote Quilibrium's use and adoption, because one of the unique attributes of crypto in general is being able to have attributable ownership of data, the idea that you own your data and you control your data, but more specifically with a privacy preserving protocol that you control who sees your data and who can have access to your data, and then compounding it a step further with the ability for decentralized compute to be able to perform things like machine learning on top of that data, that you, as an individual who's an artist, being able to contribute that into the training models, that the tagged data that associates it to you flows all the way through, such that when inference is run on that model, it attributes the ownership of the original data that was used for the production of that particular image, or that particular written work, or that particular song, that it flows back to the original creators, so that when that inference is run and is paid for, that the people involved as creators are getting a split. And so that is one of the most important things to think about when we're talking about what we're trying to do. What is unique? What is it that we are trying to accomplish that broadly others have not thought about? And it really comes down to the ability to combine, the ability to compose these like other broad concepts that are emerging in the industry, and do so in ways that are unique and novel and actually solve people's problems. I guess I wouldn't call it payments, it would be more like royalties. And then regarding the quality enforcement side of things, some people have seen some of the early days of Quilibrium, where we were building a lot more in public. We still build in public. That is something that I try very strongly to continue doing. But the way we build in public is much more about what is like the active right now, whatever the pressing moment is that people are more broadly aware of. I found that when I try to build more broadly in public and start to show early designs and early projects that aren't ready for public release, people tend to get very upset because these things, of course, take time. And as I've said many times, crypto is a very now state at the moment. And so one of the things that I had shown early on was our Q console, which is basically our answer to Amazon Web Services AWS console. And one of the things that if people paid close enough attention to what we are introducing that's rather unique, like, of course, we are introducing a encrypted end-to-end version of S3. We are adding a multi-party computation version of key management service. We are basically leveraging all the unique qualities of Quilibrium's network to provide incredible value adds to those services that we're going to be exposing through the console. But one of the things that people haven't quite picked up on, and it's probably because I haven't talked about it to a significant enough degree, I haven't pointed at it, but if you were observant enough, you would have noticed there is a social component. And that social component is actually really important because decentralization is freedom. Decentralization enables people to do things permissionlessly. And as a consequence of that permissionless nature, we have seen this industry under repeated assault through crappy scams, crappy NFT projects, crappy ICOs, crappy meme coins. And as a consequence of that, the industry has been harmed in ways that almost feel irreparable. Now, again, we are creating a decentralized protocol. So we can't just fulfill the Nintendo seal of quality. We can't just, control what is being launched on this network. It is a permissionless protocol. So this has a lot of something that you have to kind of feed back into the design of things like QConsole, and it comes back to the question of how do you add quality bar to a protocol that enables people to create whatever they want? And the answer is it's through exposure. And so the nature of what we're doing with QConsole is a decentralized application that you can manage your services in the same way that you manage things on AWS. But we are exposing elements that people can use and adopt. For example, like let's say I made a front end for managing a decentralized exchange, and I wanted to share that front end so that people could make remixes of it, that people could plug it in as like a small component. Like if I'm building a website that has a token of its own and I want people to be able to use that token, but this token's relatively new and people don't have it, I could take that DEX component, plug it into my own application, expose that as a simple component so people can make the swap into the token that they need in order to continue their action and carry on. That type of composability is something that AWS as a console does not expose. They don't have this idea of people sharing things. But what's unique about that is that because there is an easy path for people to share their applications or application components in a way that developers can adopt other people's works, there's a quality bar issue. And so by consequence, the nature of how we are generating that social component of the Q console is going to essentially be through user adoption, user voting, and user engagement around these ideas. And so essentially, we are using that as a way to decentralize that Nintendo seal of quality component to help ensure that the quality bar of the things that people are using is consistently raised higher and higher. And that social consensus is something that hasn't really been captured very well for anything yet other than actual social media. And I think that that's a unique dynamic that people haven't really come to terms with yet because there hasn't really been anything else that's done that yet. And so I think that that's going to be one of those surprising moments that is going to, people will look back on and say, this is what was unique. This is what actually made a difference in changing the way that this industry functioned for the long haul. And speaking of the long haul, the way that we're thinking about things in terms of overcoming, the bubble that's potentially actively bursting right now as we speak, is the way in which we actually design the tokenomics of the protocol. And so one of the things that people have seen as history's played out of Bitcoin, Ethereum, and others is that in order to have sustainable tokenomics, there has to be something that thinks more in terms of the longer generation by generation approach. And so the way that we incorporate generations into the actual consensus algorithm's reward output itself is literally by measuring the computational speed of the network. Now, there's been a few other projects that have basically leveraged some sort of supply-demand dynamic, and we're not quite doing that in the same way. We do have a dynamic fee market for the nature in which transactions will cost at certain points, so that if there's a hot interval that's causing a lot of friction for getting traffic to flow through successfully, obviously the fees would rise in order to address the congestion. But that's not particularly unique or novel. But what is particularly unique or novel is instead of having something that is essentially like this, depending on the protocol, they do like a 10 or 20 or 50-year horizon where the token issuance flattens out if it's like a proof of work scheme, or that there is a economic policy of a over titrating percentage over time that eventually goes to 0% issuance, and then there's just transaction fees or something as part of the nature of the protocol. Instead of doing that, we've actually taken this notion of hybridizing this proof of work system where you do have tapering issuance because there is natural stages in which the market reaches saturation. And you can see that happening in practically every industry over the course of about 10 years, over and over and over again. And instead of simply succumbing to those patterns and designing a short-term thing that will rapidly hype up, it doesn't matter that it tapers off because we're just in it for a short term. Instead, we're thinking about it for the long term, that every single one of those 10-year cycles, we want to actually capture the new generation of technology that has emerged, incentivize its adoption and use, and then also give people a new opportunity as newcomers to participate meaningfully in the protocol in ways that is very hard to do when you get into the later stages. For example, on Bitcoin, you do not have people running new miners today who have not been in the mining space to any significant degree. You'll have a few hobbyists that try this. You'll have a few people who will buy one of those mining rigs and they'll try it. but you don't actually have like large masses of people who are suddenly deciding, I'm going to become a Bitcoin miner, because realistically, the competition bar is way too high. And so mining pools have basically consolidated into a handful of like maybe three to six individual organizations, and they control the majority of the hash rate of the network. And so that's very harmful to the economic security of the network. And so very similarly with Ethereum, there is the same problem with the nature of how much capital has converged on people who are willing to put forth the effort to do validation. And so by consequence, you have Lido and Coinbase essentially being over 50% of all staked ETH. And you can make arguments that like these are good stewards of the protocol, like they have no interest in engaging in malicious ways, but that's not important. What's important is that if the protocol is intended to be decentralized, then your goal is to get as many people to actively participate in the decentralization of that protocol and not converge onto a handful of a small set of individuals. And so this is something that we're even seeing right now in our own 2.0 release, where the nature of how the mining algorithm currently works is something that's producing a lot of convergence, that there's just, it's getting into a smaller number of individual nodes that are participating. And that is not ideal. That is not something that is healthy. And that is why we are pushing so hard and so fast to get to one where the proof of meaningful work algorithm works in a completely different way, that things are more sharded out, that it is much harder for miner centralization to be a pressure of the network. And that comes back full circle to the nature of how we are planning for the long term of the network. And so these are the kinds of things that I want people to think about. Like when you look at how history repeats, there is this nature of people to just like not consider how those things happened and apply them to how things are currently happening, because they'll just argue that this is too new, this is too unique, that this won't happen again in the same way, and yet we just find ourselves making the same mistakes and making the same decisions, and same outcomes ultimately emerge. And so that's what's playing out today, and this is how we think about the nature of how this company is meant to operate, how this protocol is intended to be built, and how we intend to solve some of the most severe harms that have happened to this industry. That was a pretty long ramble, but I hope that helps, and I'll go ahead and put in that last element. I don't know if people are going to take screenshots of this, but I did want to at least have it zoomed in so people could kind of like get an idea of how we talk about the stories of how history repeats itself and how that applies to Q. All right. So that was the less developer-oriented talk. There is a little bit of developer-oriented stuff given the tech aspects that were involved, but if you're here for those pieces and you're not here for talking about actual like engineering side of things, this is basically where we'll part our ways. But for those who do want to stick around and talk about some of the broader objectives of Q, specifically in this case, we're going to be diving into Hypersync in the context of what is the difference between a hypergraph and a blockchain? How does Hypersync quickly perform synchronization of massive amounts of data between different parties? That's kind of the question we'll tackle next. And then after that, if we have enough time, hopefully we will, then we'll dive into the topic of our meta virtualization feature, which is going to be coming up later this year. And so to get started on Hypersync, we'll talk about the notion, of course. Previously, I've talked about what a hypergraph is, but short story if you haven't been around for that before. If you know what a graph is, it's pretty simple. It's either directed or undirected. It's vertices connected to each other by a series of edges. Some graphs allow you to have multiple edges connecting to the same vertices, so you'll have like two different edges. Sometimes they don't allow that. They only allow one edge. Sometimes they're directed, so there's an arrow that points one of two ways. Sometimes there's rules about the graphs where you can't have cycles in the graphs if it is a directed graph. All of these things are really cool and have led to a lot of unique technologies that have been built. Graph algorithms are used for things like input lookups, like when you are typing into a message on Google or typing into the search box on Google and it's giving you autocomplete suggestions. That's actually a graph search algorithm that's producing those set of results for you. And so graphs are really useful. But graphs don't capture all the elements of the world, all the things that we need to do to reason about or associate data with one another. There's simply not enough dimensionality. And so what hypergraphs are is essentially adding that extra degree of dimensionality. It's breaking one of the rules. Instead of an edge just being two vertexes connected to one another, it is an edge that can connect multiple vertices together. And so depending on the nature of how you draw a hypergraph or represent it, there's like two pretty common ways. You just draw like a blob around the vertices, or you'll draw this like weird funky line that looks kind of like this, that like intertwines the two connections there into one singular connection between the three. Whatever the case, a hyperedge is basically an edge that connects more vertices together. And just like regular graphs, they can have the same rules where there's arrows, that you can have the same ideas that there's like no cycles between these. And then there's also another degree of dimensionality that exists where hyperedges can also encapsulate in some systems hyperedges themselves. So an infinite recursion of hyperedges can unlock a lot of interesting data models. But what's really important for us in Quilibrium and why we are building around this this hypergraph model is the fact that hypergraphs actually can encapsulate practically every data structure that we would possibly be interested in. Hypergraphs, like if you've been in computer science in college, you've probably heard the argument that like a hash map is basically the same thing as a graph because you can represent this key value association that can point to other elements, and that essentially is the same thing mathematically as the construction of a graph. But when you get into what hyperedges can represent in terms of relationships, it unlocks a lot more than just like a simple set mechanic, a simple key value set. You can do all sorts of associations in the point where you can actually extend out the entire relational data model. So when you're talking about RDBMSs like MySQL or Postgres, if you're talking about wide column databases like Apache Cassandra or key spaces on Amazon or SiloDB, these are all things that can be represented in the hypergraph model. And when you talk about the nature of how you structure data and you enforce the validations of that data, the schema that represents that data, the schema itself can be represented on a hypergraph. And so that's the reason why we use a hypergraph, because hypergraphs can encode those relational bindings and enforce them structurally without having to actually implement those specific rules unique to each specific situation. If you instead encode it to the hypergraph will naturally enforce it through the use of its rules. So that's really cool. What does that actually mean? When you're building a application that is using blockchain, for example, a blockchain is, simply put, a collection of blocks that contains a root element in its header that points to a series of state transitions. And these state transitions are encoded as a collection of usually transactions, and they are collectively, hierarchically placed into a tree structure called a Merkle tree. And the purpose of a Merkle tree is to essentially encapsulate, and this depends on how you do it. Like if you do like zero leaves, or if you just simply traverse all up all the way. Either way, if you are constructing a Merkle tree from these events, you then essentially are taking the hash of these leaves together into the next rolling item up the tree, the next branch. So in other words, hash of transaction 1, hash of transaction 2, and then hash of those two hashes. And then the same thing at the next level, all the way up to the root. And then that root is encoded and stored in the header of the block. And then, of course, all the transactions are included in that same block. And then the network publishes that block of transactions. The reason you would do this is because you want something that sequences data in a linear fashion. You want every single event to have a strict global ordering. And that can be very useful for things that conflict with one another. Where that gets problematic is when you're trying to encode a lot of data in a lot of events. And so you'll see a lot of these networks come up with really interesting ways, like these various crypto networks that exist. They'll come up with interesting ways to try to address the speed bottleneck that happens with this. And so sometimes you'll have approaches that use sharding in order to have each individual shard of the network, whether it's a collection of addresses that have balances or a collection of like unique properties that essentially dictate that this transaction would fall under this shard, whatever strategy they're employing, they'll just have an individual quorum for each individual shard, and then collectively they will be responsible for maintaining their shard state, and then there is a larger consensus wrapped around the collection of shards. This is kind of essentially what Near protocol does with their Nightshade consensus. It's also what we use for Snapchain at Farcaster. And that works when you are limited to a small series of state changes that are going to be recognized across all of the shards. And it will work very well for high throughput situations when you know that you have a minimal amount of conflicts. And those conflicts will almost always be strictly bounded to whatever your shard logic is. In our case of Snapchain, it is based on accounts. In the case of Near protocol, I believe it's also based on accounts. But at the end of the day, the purpose of these shards is a way to essentially delegate how much of the work is being handled by each individual node that is being used for consensus. And in the typical blockchain fashion, you still end up with a header that has a block hash, and then you have a reference to the previous, I screwed that one up here. You have a reference to the previous block hash in that header. So I put this in the wrong place. Let me go ahead and change that here. Great. And then usually there's like some other hash that is basically an unforgeable value for the entirety of that block. In the case of Bitcoin, that hash is actually used to determine which is the winning block, the proof of work algorithm. But at the end of the day, like there's just some sort of basis that uniquely characterizes that block. Cool. Okay. So that's essentially the structure of a blockchain. That level of performance means that you are limited in the nature of what kind of applications you can build, as I said. Even if you do something like sharding, you still end up with this scenario where you have to limit the amount of throughput because there is an intrinsic bottleneck. No matter how far you shard the network out, there's still an intrinsic bottleneck because you still have to have block producers, and those block producers are still going to have some amount of data that they have to hold and collectively maintain consensus over for the network to not halt. So that is the problem with blockchain. And what we're doing differently with the hypergraph model is that the hypergraph model is not even something that operates as a doesn't operate as a Merkle tree, like the underlying structure of the hypergraph and how it's maintained is in a Merkle tree. We actually use a different structure. It's called a Merkle tree. It's pretty similar in the sense of how, like the purpose of it, it is a vector commitment scheme, but the difference is that we use the Merkle tree because it makes our proofs a lot smaller. And proofs actually matter for us because unlike sharded models like the one over here, that particular model requires data to still be passed around. So if I was account 1 over there and I wanted to prove to account 2 that I exist and I made these posts, I would actually have to send a whole lot of data over in order to converge on an accurate Merkle tree proof. Whereas a Merkle tree has this really cool property. So let's say that I have a singular point of data, and I've got 1 billion records that fall under this particular Merkle tree. If I wanted to prove that to you, depending on the actual branch width of the tree, and in the case of Quilibrium, our our app trees are at 64 branch width. So essentially log 1 billion records divided by log 64, that's about 4.5. So when you consider the fact that the root is shared across the network as part of our actual global consensus, we just care about that root point. That actually ends up with, in order for me to prove any piece of data on the network to you, I only have to send you 4 points. And so it would be those 4 hops on the tree that essentially encodes that piece of information. But this is a hypergraph. It's not a tree. So why is this tree here when we're talking about a hypergraph? And so this comes back around to the other scalability concern. If I wanted to prove data to you, or I needed to relay this data to you, you have to go through a lot. You have to go through the process of obviously receiving whatever that transaction was, receiving the proof that that transaction was appropriately encoded into the global state, and then I also have to evaluate that its presence in the tree was accurate, that the sequence of events wasn't played out of order, all of these different elements that relate to you having to handle a lot of encoded state transitions versus something that is just implicitly true. And so the nature of how we do things in the hypergraph for Quilibrium is that when you are making a change, that state transition has a proof associated with it. And that associated proof is essentially determining the validity of that state change in the first place. And because the amount of proofs that you have to communicate over is strictly bound to those specific linear steps in the hierarchy of the tree, you actually have enough data that you can very quickly send two pieces of information over, which would be the proof and then the lineage proof of the tree membership. And then from the tree, in order to actually represent this hypergraph data, we essentially, I believe I mentioned this in the previous stream, but I will go ahead and write it again. We essentially do a two-phase set, and that is encoded as a tree. So two-phase set is essentially adds and deletes. So if you've never done CRDTs before or conflict resolving data types, I can never remember what that is. You essentially end up with these two grow-only phases of sets that encode that data. And so one is our vertices, one is our hyperedges. And then from that, you end up with essentially 4 collections of trees. One is the additions tree, one is the deletions tree for vertices, and then the second set of those 2 trees is for hyperedges. And what you can do from that data is, because I have given you a proof of that state change, and I've given you the lineage proof of those vertexes, you also have enough information to check on the corresponding other tree to confirm that that data hasn't been deleted. And so by consequence, you have something that, based on the fact that you're only needing to keep track of the roots that are collectively being shared across the entire network, I only have to give you a very tiny amount of information for you to validate that the data is correct and that that data has not been removed due to a state change. So that actually saves you as a user of the network a lot of time and a lot of effort, or as a node on the network, a lot of processing in order to feel assured that the data and the action that is being passed to you is accurate and something that you can actively act on right now. Finally, the other aspect of this is that because this is a tree structure for these pieces of data, and because the individual commitment schemes have an intrinsic like polynomial nature into the representation of this data, you can choose what sections of the tree it is that your node is going to be able to cover. So by consequence, you can actually make your node process only a specific subset of the shards of data, such that you can cover what is capable of your node to be able to handle. So in other words, you can limit it. I'm only going to cover half the network. Okay, then I've only covered half the network, and it's easy to divide that. Things like that. I am unfortunately running very low on battery, and I've also hit the time limit, so I'm going to wrap this up real quick. So this difference of why we have this is important for being able to represent incredibly large amounts of data, perform incredibly large amounts of operations on that data very quickly, and most importantly, be able to synchronize those changes on that data very quickly, which is the reason why when I did the replay earlier, I was able to evaluate over 1 billion state changes in approximately 23 minutes, which is somewhere around 750 operations per second. And that's just for a single shard. When you expand this out to the overall number of shards that exist on the network, that actually becomes really, really impressive in terms of how fast you can scale out the network and how widely you can scale out the network. And so that's kind of the reason why we're doing hypergraphs versus blockchain as our data structure of consensus. And then additionally, Hypersync is essentially just a tree walk algorithm where both parties are walking down the tree simultaneously, picking out the things that don't match. Because again, this is a polynomial commitment scheme, you will know at a given branch whether or not there is any further to go, because it will either have the same proof or it won't, and that'll tell you to keep going. And that works relatively quickly now that we have worked out all the bugs, if you have been following the testnet channel. So I hope that helps in explaining the difference between those two things. I'm sorry to get so abrupt on the wrap-up, but unfortunately I do not have my charger cable on me at the moment, and I am going to have to end the stream before the stream ends itself. So let me take a moment to ask folks if you have any questions. This would be the time to do it while I still have 8% battery life left. And then we'll wrap it up from there. Okay. Okay, so I see a few questions. There are a lot of questions on Twitter, primarily by Easy Trades. Unfortunately, I cannot answer some of those questions because those are price related and speculation related. And as we said at the beginning, we do not encourage or condone speculative mindsets around the utility token of the network, so we won't comment on that, simply put. In terms of, yeah, let's see if there's, okay. How many people are developing 2.1? We have, so at the company, we now have 3 individuals that are working at the company, excluding myself, obviously. I remain the unpaid intern of Q. Outside of Q, there have been 37 contributors to the protocol itself, some at varying degrees of capacity than others. So some have contributed a lot more, some have contributed only a little bit, and that's just in terms of actual code. There's also been a few contributors who have contributed reports that either were performance related or even vulnerability reports historically, and additionally reported here's where it happened, here's why it happened. So it's more than just like a hey, this is happening report, but rather here's how this is actually happening and here's what you can do to fix it. So there are people even outside the 37 developers that are directly on the Git log as being contributors to the protocol. Link to the testnet channel. So we have 2 testnet channels. There's one on the community Discord and there's one on the Node Runners Telegram. We were originally trying to limit the Telegram because we were wanting to get people onto Quorum. Unfortunately, ironically, this Hypersync algorithm is something that we need to get onto Quorum so that we can resolve one of the most painful bugs Quorum is currently experiencing. Once we do that, then we'll move everything over to Quorum, but that has gotten in the way of that. Okay, I think that's it. I don't see any more questions, so I will go ahead and wrap it up here. All right, everybody. Thanks for attending, and I guess we'll have to